Good morning, engineering 2. Woo. Start talking about auxiliary views. Let me bring this one up. Auxiliary views, what do we need then? Well, I'm going to assume that you remember, especially now that we start to dimension on the place that you're supposed to dimension. You guys probably have noticed that when I go and I tell you, hey, dimension a feature, you do not dimension to hidden lines. If you have a feature that is hidden, then I don't dimension it. Well, there are going to be certain cases where you might have things that are on an inclined face. Let's say that we have this case, something that looks like this. And I have a hole that is on this face. If I were to look at that, it will look like this. So if I were to look at the side view, or in this case the front view, it will look like this, just a hole that goes on the white room. Okay, if I were to look at this view, I cannot dimension it. If I were to create a top view, I cannot see the hole where the true size of the hole is, where it actually can dimension off of the edges. I cannot do it on the side view. For that reason, we need to understand what are auxiliary views. Up to now, what you guys have done is your regular orthographic views, which are normal surfaces, perpendicular surfaces, orthogonal surfaces. They're the same naming, different thing. A normal, different naming, same thing. The normal surface is a plane surface that is parallel to a plane of projection. What does that mean? This is my plane of projection. This is my surface. And as you guys can see, the plane of projection is parallel to the surface. If I were to put two planes right next to each other, one of them you will see it like a surface, and the other one you will see it as a line. A normal surface appears at true size and shape on the plane in which it is parallel. For example, the one that is here, that is the surface that I'm doing. Looking at from the top, it will be a true shape, a true size. And as a vertical or horizontal line on adjacent planes or projections. For example, the top view, I see it as a surface. Parallel will be the top view, which will give me the true size. And if I were to look at either the side view, the front view, I would see this line, which will be a line. Or if I were to look at on the side view, I would see this line, which also will be a true size, but will only be a line. It will be an edge of the plane. Remember, the whole idea is you dimension where the shape truly occurs. In some cases, we're going to require to do things that are on an inclined surface. So let's take a look at an inclined surface. And remember that you guys remember this assignment that you guys did. That had an inclined surface. And then I want to tell you why we didn't clear the orthogonal views in just a second, but there are times that there is inclined surfaces that we need to account for. We need to create an inclined surface drawing, per se. That's what. Okay, so inclined surfaces. An inclined surface is a plane surface that is perpendicular to one plane of projection, but inclined to an adjacent plane. What does that mean? If I were to look at this face, which is the inclined surface, and if I were to create a projection plane from the inclined surface, it will be parallel to that one, which is this one. And so now you have a plane of projection that you have inclined for your real surface. And if I were to look at the other surface, let's say the front view in this case, it will be perpendicular. So if you guys were to look at this plane and this other plane, the angle between them is perpendicular. That's what they're trying to tell you. An inclined surface will project as a straight line on the plane which it is perpendicular. As you guys could see here, there is a line that is just a line in the plane that is perpendicular. And it will appear foreshortened on the planes to which it is inclined. In other words, if I were to look at this green plane, and I were to look on the top view, where I am projecting, let's call this guy A, B, C, and D. If I were to look at the top view, this view, even when it is displaying the inclined surface, is not as its true size. It's actually foreshortened. It's a little bit smaller. If I were to look at the side view, same concept will happen. It will be a little bit foreshortened, smaller. And if I were to do the plane perpendicular to the inclined projection plane, it will appear as a line. which is what you guys see here. For to explain what it says. The degree of foreshortening being proportional to the angle of the inclination. Now, the one that you guys will see here, you guys will notice, and it doesn't necessarily have to be a view like the one that we did here. We can also have an incline on the top view. Again, in the other plane, you will see a foreshorten, and in here you will see actually a line of a true length. Only one edge will be a true length, which in this case will be this one, true length line. Okay, for example, this one, this is this plane. That one will be a true length right here. And then this plane will be foreshortened. So I'm projecting it this way. And also this plane will be foreshortened. It's not the true size. Okay. That also can have something that we call it oblique views. Oblique views, actually, they're a little bit more complex. Let's say this is an introductory class. Engineering 2, we barely touch on graphics. You guys touch a lot of materials, but we don't really dig too much into that. But believe me, I teach you enough to allow you to defend yourself. We also have oblique surfaces. An oblique surface is a plane that is oblique to all planes of projection. It's not perpendicular to any plane. So use a plane somewhere in the middle, right? It's not parallel to any surfaces. It is not perpendicular to any surfaces. It's somewhere in the middle, like the one that you see there. It cannot appear as a line in any view. Since it is not parallel to any plane, it cannot appear at true size in any view. Thus, an oblique surface always appears as foreshortened surfaces in all three views. Okay, we are not actually going to do oblique surfaces, but here you guys will notice what it is. Here you have a plane, then you start marking all these A to B's. So come over here, you guys will notice that it went and it labeled every point like that. Boom, boom. Creating these lines, boom, 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 and then clean it up again. That was for the class. If I were to do something like this, most likely we'll do it with a model. Okay, let's talk about auxiliary views, which is the topic of today. That's why we need to talk about inclined planes and inclined surfaces. Many objects have inclined surfaces that are not always parallel to the regular planes of projection. For example, the front view, in this case, is correct as shown, but the top and the right side view do not correctly represent the inclined surface. To truly represent the inclined surfaces, as to show the true side shape, I need to create an auxiliary view. The auxiliary view has a line of sight that is perpendicular to the inclined surfaces. So, if I were to come over here, this is, if I can draw it in isometric view. So an isometric view will look something like this. And again, sorry, I'm drawing with my mouse. So it will look like that, right? If I were to look from the top, I will get this view, which will give me a foreshortening, right? A little bit smaller. If I were to go that way, this surface right here will also be foreshortened. If I were to look at the top view, I will only see one edge at true size. If I want to get the true size, I need to look directly at it. And the way I do directly at it is by creating a plane that is parallel to this one. Right here, parallel to this one. And what we're going to do is we're going to create a bunch of projection lines. And these projection lines are going to be at 90 degrees. 90 degrees to each other. Okay. So this is the algorithm to create auxiliary views. Step number 1. The auxiliary view is projected from the main orthogonal view that it shows the inclined plane as an edge, which in this case, this is the inclined surface, and in this case, this one is the inclined surface. So when I go and I create my auxiliary view, I have to look for the inclined surfaces, and then I project based on that one. If I were to look at the regular orthogonal views, and I were to look for the true shape, where I can actually dimension the true size of the inclined surfaces, and I were to open my box, I will have the front, the top, the left, the right, the bottom, and the back side views. None of them will allow me to displace the true size of my box. Everywhere that I will see it foreshortened. But this is the back, so I don't even see it. And on the side view, on the front and the back view, I will see it as a line, and in here is hidden, right? So none of the views gives me the true size. That's why I need to learn how to make an auxiliary view. Step number 1. You are going to create your front, your top, and your side view. As you are creating your front, your top, and your side view, make sure that you use projection lines. I want to make a line projection. In other words, I don't know if you guys remember when you created your views, the first thing that you did is to make a square. Right? Make a square so I can explain. Because you kind of already did it, but you didn't know that you were using projection lines. So projection lines are lines that, again, all these views communicate with each other. Okay, so for example, here is the left side. That's the left side. If I were to project the line, the views will should align with each other, right? And then if I were to project this edge, this point should align with the one on the top. If I were to project the width should align with the view on the top. If I were to go from the bottom, the height right here, should project to the other view. Both of them should have the same height. This one right here, the one that you guys see, this one is what we call it a miter line. And the miter line will allow us to actually do my auxiliary views. So what is this miter line? All it is a 45-degree line. I'm going to go from the corner on my part, I'm going to push it up. I'm going to go from the corner on my part, I'm going to push it sideways. I'm going to go from here to there, I'm going to push it here, and then I'm going to push it there. And if I were to connect these 2 points and measure the angle from horizontal, it will be 45 degrees. And you guys have seen it before. You guys dimension from the back side of the part, right? And then until you go from the back side towards the front side. This is pretty much part of the miter line. We're actually going to start looking more into it, a little bit more in depth. Okay, so first you make your views. Second, many books, what they will do is they will start putting some labels, some of the points that define this auxiliary view. So here they call it A, then here they call it B, they call it C, they call it D, right? And then when they look at the front view, they say, okay, so if I want to look at the front view from here, let me see if I can redraw it again. Like this, right? Sorry, I'm drawing with my mouse. This one is A, this one is B, this one is C, this one is D, right? So they say, you know what, when I look at it from the top, that is A, B, C, D, right? I'm looking from the top. And when I want to look at it from the side view, I will see A and B. That's why you see A and B right there. I mean, from the front, right? I will see A and B. And from here to here, I will see D and C, which is what you see there. And then if I want to look at it from the side view, I will see A and B, D and C, which is what you see here. A, B, D, and C. Okay? So they label the surfaces and they give it a letter. You can also give it a number. Then, they create a line, call it the reference line. By the way, this reference line could be right next to the edge, or it could be a little bit more over here. It doesn't really matter. This reference line is the edge of the box. So if I were to come over here, let me see if I can redraw it again. Something like this, something like that, right? Let me see if I can change the color to a different line. Let's make it red. So if I were to make a box right here, right there, where my part lives, right? And if I were to look at it from the side view, because this is the side view, right? What I will see is the face, which is actually the edge of my box, right? It's just the reference line. Okay. After you have the reference line, and again, this is the book, the way that the book does. I'm going to do it a little bit different. I think my way is probably a little bit easier, but I got to explain in the book way first. Okay, so you are going to use the reference line and you're going to measure this direction. Okay, you can also use this reference line, by the way, and also over here, and you can measure that direction. And again, the whole reason why is because, let me draw it again, making sure you guys understand. So this is my box. Sorry for the cricket box. Let me make it blue for the part that's going to go inside. So it's going to look like that, and like that, right? And again, remember that my edges or my reference lines, it is going to be this one, right? If I were to look at it from the front view, I will see this line, right? This one, this line. And if I were to look at it from the top view, I will see this line, which again is the same one. It's the same plane. This is the edge of the box. Now, if I want to know the depth of the guy, if I want to know the depth of that guy, all I have to go is I need to, what I'm trying to do right now, guys, makes sense. I'm trying to create a different color. I'm trying to create a plane, this plane right here, that is perpendicular to that plane, right? Which is actually the plane that I'm creating right now, which is this one, right here. Okay. And if I want to do that, I need to know the side of my green plane. Maybe highlight it, maybe make a different color. highlight it. I'm going to make it, I don't know, green. So this plane right here is meant to represent this plane right here. This red line right here, this red line here represents the orange plane. Uh, the side length of the green plane, I'm going to get it from here. Right? So it will give me the true size length. And the depth, as I'm measuring that way, will be this one. Right? I'm measuring that way. And if I were to want to go using this plane instead, I have to measure that way. That way it will give me the true depth of the green plane, which is this distance. So this distance will be this distance, or this distance, right? This is the width of my plane. Again, I can create this plane, and that's why you guys will notice that they create a line. They call it reference line, right? The reference line. Okay, now in terms of the way the book explains it, they say, you know what? I'm going to grab those points, A, B, C, D, A, B, C, D, all and label everywhere. Find the line where I have the true size of the incline. And then make a bunch of lines that are 90 degrees with each other, right? It's 90 degrees, perpendicular to each other. Just go crazy at it. And then go and measure this way and apply those dimensions here. For example, dimension from A to D, I can measure in this view, and then I measure with my ruler from here to there, that will be the same view right here. And since this one is just a square, the distance from D to C will be the same as the distance from here to there. Boom. Then you usually like to recheck your work, right? You want to make sure that things look clean. You guys will notice that on my auxiliary view, I did not project it this. I could have, right? My view could have actually looked like this, right? My view could have actually looked like this if I were to project this plane. But I did not do it. Why? Because the whole idea of these auxiliary views is to be able to find the surface that is inclined to that edge, or surface with surface, right? Parallel with each other. I don't need the green. And since I don't need the green, I don't put the green. I just put the true size of the face that I'm trying to achieve. Also, since my whole idea is to see what's happening on that surface, I don't care if I were to have another line. So I don't know, let me go bring that one up, right? You guys remember I have this plane that I could have projected, and I could also project this line and then put a bunch of hidden lines right here. I could have, but I'm not doing it because I'm not gaining anything by putting those hidden lines. So anything that gets extra, I delete it. Anything that is hidden, I delete it. And you only get to put them there if it is needed for clarity. In my case, I don't need it. It's just a square. And at this point of time, it's your prerogative or decision. In my case, I will let you know. Most likely, since you guys are learning, I will let you know when you need it. Okay, now, you guys are wondering, Professor Scalona, I just did a block. I just did a block, and my block had an inclined surface. I think your block, I don't exactly remember how your block looks. If I recall correctly, your block looked something like this. Maybe. I think it had a hole, something like that. I don't remember. I'm going to assume it looks like this. It's been a while. I don't do it. You guys are the ones that do it. And I only look at it when you guys submit it to me. Okay. You guys will notice that I had an inclined surface. In your Professor Scalona, if I did that one, why you didn't make me do an auxiliary view? The reason why I did not make you do an auxiliary view is because you didn't need it. You only put the views that are necessary to convey your design intent and no others. So I did not show you how to make auxiliary views because you didn't need to do auxiliary views. But in your upcoming assignments, you will need to know how to make auxiliary views because you will need them. Do you need auxiliary views whenever you have an inclined surface? No, you only need it when you have features that live within the inclined surfaces that you need to dimension or you need to define and locate. For example, here I have two parts. Let's take a look at the first part. Let's see. I'm going to start creating, I mean, you will do it real quick sketch, right? And you're like, okay, so I need a front view. Okay, so I have a view, and again, I'm going to omit the hidden lines. Okay, so I mean, I could, but I'm going to omit it for sake of clarity. I'm going to come over here, I'm going to create a top view. So my top view will look something like this, right? And then I will have a line that looks like this, like that, and then I will have a little thing that will look like this, right? And then if I were to look at the side view will look something like this. Right? And then you ask yourself, okay, do I need the view? I don't know. Let's see. What do I need this view for? Well, in that view, I can get the width. And it seems to me here I have a little notch that is triangular, so I need it, right? So check, need it. And then you come over here to this view and you're like, oh, it seems to me that I have a couple of walls that are half an inch, right? And I also have this thing that it has a certain depth, right? Which I need it. So check, I need this guy. And then you look at the top. Okay, so what can I get from here? Okay, from here I can get my width. Oh shit, I already have it here. So I don't need it. What about this one? Oh, here I can get my depth. Oh shoot, I can also get it from this view, right? Because the depth, you can see it on the side view as well. So in other words, I don't need the top view. Now, do I need an auxiliary view? Then you ask yourself, have I completely defined my whole geometry within the views I have? Yeah, I don't think I need anything else. I have the width, the height, the depth. I have the thickness of the walls, and I have the notch angle, which is 60 degrees. I don't need other views. So in this case, the only thing that I need is the front and the side view. What about if I were to look at the other one? Let's take a look at the other one. So I'm going to start with green again. So let's go blue. Blue. What do I see here? Okay, so if I were to look at the front view, my front view will look something like this. And then I will have a little in there, right? Again, sorry for the clicking lines. I'm drawing with my mouse. And if I were to look at the side view, let's see, the thing will go down, will go up, will look like this. And then this guy somewhere here will go and will look like that. And then I will have a line like this. You don't have this line, by the way. Okay? And if I were to look at the top view will look something like this. Right? Okay, then you ask yourself, okay, so what views do I need? Let's see. What do I need this view? Oh, look at this. I got a triangular notch that I need to locate. And also give me the height, right? And it seems to me it also gives me the width. So let's keep that one. So since I got the triangular notch, I need this view. And then I look at the top, right? So the top, I can get that distance. And it seems to me I also can get that distance. And I can get this distance. And guess what? It seems to me I can also get the depth, right? Pretty good. So it seems to me I have two notches here, so I need this view. And then I go to the side view. And you're like, okay, what can I get from here? Well, from here I can get the height. Oh shoot, I already have it, so I don't need it. Oh, from here I can get the depth. Oh shoot, I already have it in the other view, so I don't really need it. So what do I need this view? I don't need it. Do I need an inclined surface? We need to actually come up with an auxiliary view of this. No, I have already conveyed my design intent. So I don't need the side view, I don't need an auxiliary view. Hopefully that makes sense. There is no apparent reason why the above objects will need an auxiliary view. There is nothing happening on the inclined surfaces that requires true views of the surfaces. So what do you need? Okay, let's take a look at it. Okay, so now, it's getting a little bit more complex. In here, I have a hole that is on an inclined surfaces. So let's see how many views what I need here. So let me go and make it let's make it blue. So if I were to create a side view, the guy will look like that, will look like this. And again, sorry for the sketch. It will look something like that. And then this guy will look like this. And again, I'm not going to do hidden lines. And somewhere here I will have this lip, which is the round portion here, right? Okay, so what do I need this one? Now it says to me that I have some kind of an angle it's looking like, right? I may need that guy. So it has this inclined tube. Let's take a look at the top. We need the top. Alright, so if I were to look at the top, that guy will look like this, and then this guy will look like that. Boom. And somewhere over here will look like this, and then single look like this. Again, it seems to me it might be symmetric, almost like symmetric. And again, here I got the holes, have another hole, and then I have a hole that is inclined. Right, looking at that part. And now if I were to look at the side view, so the side view will have like an ellipse like this, another one like this, then this guy will look like that, and then I will have a square like this, and then I will have a lip. Right? And again, I'm not putting any hidden lines. And then you'll be like, okay, so what do I need this view? Let's see. Do I need this front view? Well, I need it because I have this inclined tube. So check it. I need to define it. I need this top view. Well, I have a couple of holes that I only can see them there. Right? These holes right here. So I need this view. Sure. It also allows me to give me some depth, right? And then you look at this side view. Okay, so what can I get from this side view? Well, I can get the height. Well, I can also get it from here. I can get the width. Actually, I don't need this view. It's no need for me. If I have anything that I'm gaining, to have that view. Now, I still missing the hole that is on the inclined surface. And I cannot see it here. And in here it looks like an ellipse. So, guess what? I need to have a projection and define my plane where I will be able to see the hole. So I need it. Because I am having a feature that lives on an inclined surface. And then you guys will notice the same happens to this one. In this case, I have a couple of holes that are being located based on the inclined surface. Instead they live on the inclined surface, guess what? I need to put them. Locate the holes and create a view where I could actually have and be able to locate them. So, you do not dimension where the features do not appear at true size or at true shape. And I think that's one I hope that you guys have noticed that every time that we do dimensioning exercises, you need to have a critical thinking. Okay, where am I going to put it? Just don't go click everywhere and find out put dimensions all over the place. There is a way of doing it, the right way. Okay, we do not dimension to holes that look like ellipses. Dimensions are where the true shape occurs. On the other hand, the objects that you guys see here, they require auxiliary views to show the inner and outer diameter of the cylinder on the left side and the hole diameter and the location of the bracket on the right side, because the holes in this case occur on an inclined surfaces, and I need to locate them and I need to hold them out, and you do it when you can see the true shape. Let me get some more water. Okay, let me come over here and let me see if I can draw this with my blue color to give us a better idea of what it is. So what it seems to me, it looks like this, and then it looks like that, something like this, and then it looks like that, and then it goes on an angle, and then actually this guy's kind of like an angle, like this too, something like that, something like that. And again, this guy doesn't exist, that one doesn't exist. Okay. And somewhere here, here, I have a little notch that it continues. I don't know if you guys could see it. I probably didn't make the best drawing in the world, but hopefully it makes sense. Let me see if I can reduce the thing and I can make it better. Maybe a little more. Let's make it like a 2. A 1, that's fine. No, maybe like a 3. There we go. So this here, again, I'm just gonna do the side so you guys could see it, and then maybe do the top lip. This here, and again, sorry for me drawing with the pen, with the mouse, but hopefully it makes sense. So you see the little cut right here is if I were to come over here and create a view, right, I'll be able to see that little notch that you guys see there, right? And if I were to do the regular orthogonal views looking from the top, I will create this view. If I were to create my front view, I will create this view. And if I were to create my side view, I will not gain anything. That's why you won't even see it there. Now, in order to be able to come up and see the little notch that you guys see there, first I need to create an auxiliary view to represent a plane of projection that is parallel to the surface, which is this one. And then after I create the plane of projection, then I create another surface that will represent the notch, which is what you guys see here. Hopefully that makes sense. Sometimes the primary auxiliary views is not enough to fully illustrate an object, and a secondary auxiliary view is needed. A secondary auxiliary view is projected directly from the auxiliary view. Many times the auxiliary view and or some other views cannot be fully completed until the secondary view has been completed first. Okay, so we need our inclined surfaces because sometimes I have features that live on the inclined surfaces. Sometimes I have features that live on a secondary inclined surfaces, which is not my regular orthogonal views. For that, we need to learn how to do auxiliary views, which live on the inclined surface, or live on the parallel plane that is parallel to the surface that is inclined. You have to put those views only when they are required. Now, back in the day, we used to do this by hand. It took forever. You need to actually remember. I think when I was a youngster, young, I mean like 12 years old, I wanted to be an artist. You know, people with dreams. I wanted to be an artist, and the reason why I got into, I think I got into architecture first. Architecture back in the day. They used to teach architecture when I was 12, 13 years old. Just imagine, huh? And I got into architecture because I wanted to draw all the time. I was really good at drawing, and I used to love to draw. And they used to make us do a bunch of drawings like these ones, not necessarily more architectural looking like, um, but it was considered an art to do all these views. Now we're doing it with, we do a little model and then we just click, 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 boom, views. Front, top, side, view, auxiliary view, a little bit detail, a bit of break lines, half sections, full sections, so forth. Just click, 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 click. Um, However, back in the day, they noticed that there are certain things in these views that are not really needed. You guys remember when I did the exercise of saying, okay, what do I need in this view? Um, it's because the features occur in a certain view, not necessarily in all the views. And for that reason, sometimes it's back in the day, it was optional for you to have the whole view completed. And you can actually do partial views. And what you did is kind of like you crop the view. So for example, if I were to look at this view, okay, let me see if I can model this. It will make a little more sense. Let's say I'm going to go over here. And again, sorry if my thing is not the best drawing. I'm doing it with my mouse, right? And again, this line doesn't exist. And here I got somewhere the hole. And then it seems to me this guy goes like this. And then this guy goes like that. And then this guy goes like this. And then here I got a hole. Here I got another hole. And here I got a slot. Okay. Hopefully that makes a little more sense. Right. So you come over here and you're like, okay, I'm going to create my views. Why do I need this view? Okay, I need this view because it seems to me that it has a little lip, right? And I need to dimension that thickness where I can see them. I cannot see it on the top view, and I don't even have I have a side view, but I can't see the thickness. All right, so I need that one. I can also get the width from here, and it seems to me this guy has kind of like an angle, right? So I might need this view to be able to locate that cylinder. So yes, I need this view. It seems to me I need the whole view. I don't have anything else. The whole view will tell me something about this part. Okay, then I come over here to the top view. Right. In this top view, it seems to me that it has a slot. Well, that slot, I can only see it on the top view. I cannot see it on the side view at all. And in the front view, I see it like a bunch of hidden lines, so it's not visible to me. I need this view, and it seems to me that it also has like a little radius. And that radius, right next to the slot, I can only see it in the top view. I cannot see it in the front view. And then I have this cylinder. Okay? And this cylinder seems to me it's not a true size. In fact, the hole that is in there, I cannot see it. My cylinder that it looks like that, I cannot see it. The width, I can already get it from here. And the depth, well, I can get it from another view. So maybe what I can do is I can chop it. And again, this is what I was kind of about thinking of back in the day, because back in the day, we didn't need, we used to do it by hand. Well, in you guys case, you're going to do it by hand. So guess what? You just might want to do what I'm doing. So in my case, I'm saying, you know what, the slot is what is important for me, so I'm going to get rid of this. I don't really need it. I can get the depth somewhere else, and my shape of my cylinder, as long as I tell it that it's a diameter, it should be good. Right? And you can call out diameters in the view, maybe here, right? You can call these diameters here, because in here you will see it at two sides, in the auxiliary view, right? Then you come over here to the side view. You're like, okay, so what do I need the side view? Okay, so it seems to me that here I got two holes, and that's the only place where I could see them. I cannot see them here. I cannot see them here. I cannot see them on the auxiliary view, so I need this view. It seems to me that I have a couple of fillets there. And I think that's it, man. The inclined surface on the top, I don't need it, so I could actually get rid of it, like that. And again, my auxiliary view, I need it because I have a hole. And in order to be able to see the hole, I need to project it to a plane of projection that is parallel to the edge, where I can see the hole. So, sometimes, oh, look at this, I even cut even more. Somewhere here, right? Sometimes you can create partial auxiliary views. And again, at this point of time, you need to ensure that you know where the features belong, so you don't get rid of stuff that you need actually. If I were to look at the top, I'm able to find the slot in the radiuses. If I were to look at the side, I could find those holes in the radiuses, anything to do with this. And if I were to look at this auxiliary view, I'm able to see the shape. Boom. My side view, my front view says to me I need the whole thing. Okay, now let's take a look at your assignment, and then we'll do it most likely next time we meet, maybe on Thursday. So I'm going to come over here, I'm going to look at homework, and you are on auxiliary views, and I believe I'm going to open mine. Sometimes I go into notes. Okay, so this is your homework. Maybe I see I made it a little cleaner. Maybe I added the table somewhere there, but it should be similar to yours. Make a proportion and dimension sketches, so you're not going to dimension it, of the holder block and guide block shown below. Each sketch should be on a sheet of engineering computation paper oriented in landscape, as in our first sketching exercises. You are going to have, seems to be, two blocks, the holder block and the guide bracket. And it seems to me the sketch in this one, which is the holder block, consists of the front view, the side view, and the auxiliary view. Again, do not dimension, but leave room between the views for dimensioning. The material is going to be brass, includes approximate scale, the name, the title, etc. So similar to your previous assignment that you did your dimensioning, but you don't dimension. Okay. Let's take a look at the bottom one. The bottom one, this one, you are going to do, you're going to do another sketch, you're going to do a front view, you're going to do a partial, that's what we talk about partial views, huh? You're going to be doing a partial bottom view, and again, it seems to me that this hole, it is drilled from the bottom, counterboard from the bottom, that's why you need a bottom, because you need to be able to see where the counterboard is. The primary auxiliary view, we're going to create a primary view, so we're going to reflect that way, right? And then, let me see, primary auxiliary view and the secondary auxiliary view. Secondary view will be coming to looking that way, or coming to looking that way. So I create one and then create the other one. Similar to the lecture that we were talking about. The material is going to be mild steel, include approximate scale, name, title, etc. So since we're going to place this on the drawing, we'll need to do a little bit of scaling, a little bit of planning of how we're going to make it happen. Since we're going to do that, and we need to actually measure it proportionally, we are going to need most likely our, is this a hand sketch? Let me see. Proportion and dimension sketch. I don't think they say anything about oriented, each sketch should be sheet of engineering paper. Okay, so this one doesn't say hand sketch, guys, which means yes, you can use a ruler. Okay. In fact, it seems to me we're going to need a ruler if we actually want to do a good job. And again, most likely next time we meet, which will be on Thursday, I'm going to do my best to get both of them out of the way. Good morning, engineering 2. Woo. Can you guys hear me? Somebody say yes, por favor. Let's start by sharing my actually no, let's not start there. Let's take a look at your assignments. I believe I have an electronic version of it that we can look at before we go on the paper. Let me see. Student folder, E-Tech, engineering 2, share folder, and actually let me go to mine instead. Professor, engineering 2, and then we got homeworks, and you should be doing homework 10, or I'm going to be doing homework 10. Let's take a look at it really quick. Let me get some smart water. Do not forget your smart water. Perfect. All right. What you guys see here, it is a electronic version of what I did in order for me not to spend a lot of time doing my conversion. So let me tell you what I did. Let me actually look at the assignment, and then I tell you what I did. So I believe, not this one, this one. This is your assignment, and it's telling you make a proportional and dimensional sketch on holder and guide block. Shown below, each sketch should be on a sheet of engineering computation paper oriented in landscape, as in our first sketching exercise. The holder block, which is what you guys could see, the sketch should consist of the front view, the side view, and the auxiliary view. Boom. Important. Do not dimension, but leave enough room between the views for dimensions. Material, it is brass, so I guess we're going to have to add some notes. Include the approximate scale, the name, the title, etc. Okay. let's jump to this. Let me tell you what I did for this assignment. Let me minimize this, and let me bring the camera right here. Let's do a good space. All right. So, and again, sorry if this guy is not perfect. I'm drawing the angle, but I'm gonna do my best to make it as clear and legible as possible. Let me say by here. It's very close to the drawing area. Okay, this is your assignment. This is your assignment right here. And again, I added a bunch of notes. It should be good. All right, so it's telling me that I want to go and I gotta put this in one in here, and I need the front. I need the top view. Let me see. No, I need the front. I need the side view. It's right here. Front, side view, and the auxiliary view. I needed to determine a scale that I was going to use for me to draw it. So in my case, we can actually determine the scale. I believe I can already did. I went over here and I put my cheat sheet, which you should have it in your cheat sheet somewhere. I'll give you a package with this table with decimal equivalents. The numbers that they're giving me, they are giving it to me in decimal form. And since I'm going to be drafting it in on engineering paper, and my graduation on my ruler, it is to 1/16 of an inch. What I want to do is I want to grab those decimal places and I want to get them into a ruler format that I can understand. So for example, here I have 2.8, right? And if I go over here at 2.8, it seems to me like the closest that I could see here for 2.8 will be 2.81. In this case, since the minimum division that I have on my ruler is 1/16, I want to make increments of 16ths. So when I draw it, I'm not going to draw it at 2.81. I'm going to draw it at 2 13/16. Hopefully that makes sense. So I went to all the dimensions. You guys can see them right here. I got in that 0.8 made it 13/16. That 0.44 I made it 2 7/16. 3/8 I made it I think it's 0.4. I made it actually somewhere between 3/8 and 7/16. Because 0.4 is somewhere in the middle, right? So 3/8 and 7/16 is 3/8, right? And then 7/16 is somewhere here, so it's going to be somewhere in the middle. Okay, let's see it. So this is 3/8, this is 7/16, and somewhere in the middle will be my 0.4, right? Which is say, you know what? Since really matter, I can do 30 seconds of an inch. By the way, I give you a cheat sheet that contains 30 seconds of an inch, but in terms of drafting purposes, since I'm going to do it with a pencil, it will not even matter. Since I'm also going to make it thick lines because they're visible lines. So I say, you know what, I'm just going to make it 3/8. And again, I did the same exercise with each of them. Now that I have that, then I can determine what scale I'm going to be using. Okay, so I want to give me an idea of what is going to be the size of my boxes before I actually start. So if I were to come over here with my boxes, I don't have the top, right? So I can get rid of the top. It tells you you need the top. I have an auxiliary view. I know that from here to here is 2 13/16. And in terms of depth, it seems to me it's also 2 13/16. And in terms of the height, it seems to me is 2 7/16. And I also need some space over here, right? Which is going to be my auxiliary view, which is pretty much going to tell me my inclined surface. So my inclined surface is going to look somewhere there. Right? It's going to be somewhere here. And it's going to be, it seems to me, it's about a little bit over 2 inches. See a bigger over than 2 inches. And width-wise, it seems to me, it's about 2 inches. Right? So let's give it a approximate what scale I'm going to use. For that, I am going to grab my drawing area, and I want to try to represent. Sorry, too many papers here. I'm going to grab my drawing area, and I want to see where would these 2 13/16 be. Okay, so that is 2, 4, 6, 8, 10, 12, 13/16 is right there. I'm going to put it right there. 2 13/16 is here. Drawing area. 2 13/16 will be right there. 2 7/16 will be a little bit less than 2 13/16, which will be there. So my block will fit somewhere here, somewhere there, and it seems to me I will have enough space, which it gives me and leads me to come and draw this 1 to 1. That's pretty much what I'm going to do. Alright, so let's start with a box 2 and 13/16. And again, you guys will do the math where you guys can center your views. Try to make these guys as low as possible, as apart as possible. Let's say maybe give it space in the middle, maybe like 2 inches. Let's see, when you go in your center, you will give about 2 inches. That way you will have enough space for dimensions, and if you go and you do your auxiliary view, also move it away, let's say another, let's call it about another 2 inches from the part. That will give you enough room to put any dimensions, as indicated on the assignment. So let's start with the 2 and 13/16 super quick. 2 and 13/16, and again, I don't have engineering paper, but you will, which will allow you to center a little bit. I don't have time, that's the problem. So 2, 4, 6, 8, 10, 12, 13, 16. And then move. And let's do another one. Let's put it about 2 inches apart. Let's see about there. And then we're going to do 2 and 13/16. That's 2, 4, 6, 8, 10, 12, 13, 16 right there. Boom. And then in terms of the height was 2 and 7/16. So that's 2, 4, 6, 7/16. Somewhere about there. Boom. Let's do 2, 4, 6, 7/16. Somewhere about there. And 2 and 7/16 about here. And 2 and 7/16 will be about there. Right? Let me put them all together. And again, in your guys' case, you guys will have your squares. I don't have squares, and I'm drawing at the incline, which makes it much harder. Let me make that a little bit more straight. Okay. It's pretty good for common purposes. Okay. I'm also going to put an auxiliary view, but I'm going to hold on the auxiliary view. Let's focus on the front view first. I'm going to fold this in half. Let's focus on this. And I'm going to put this on top of it, so I don't have to move it. Let's focus on the front view. Okay, so it's telling me that it's 3/8 of an inch. So I'm going to come over here, 3/8 of an inch, about 3/8 of an inch. Boom, boom, right? It seems to me that this is 45 degrees, and this one's 13/16. So if I come over here, 13/16, that will be 2, 4, 6, 8, 10, 10, 12, 13/16 right there. 2, 4, 6, 8, 10, 12, 13/16. If this is 45 degrees, that means 13/16 will also go on the bottom. So that is 2, 4, 6, 8, 10, 12, 13/16 somewhere over here. And that will make the 45 degrees that I want, right? It seems to me that the height over here, it is 15/16. So I'm going to come over here and put 15/16, which is right there. And then I can connect both of them super quick. Oops, I can't, right? Because that one is 45 degrees, which means if this one is 15/16 right there, in order to make the 45, I need to look at the top, which it seems to me is 1.5, and push it over here to make the 45 degrees. And then right after that, I will have my 45 degrees. And again, remember, because when you have a 45 degrees, whatever goes here has to go here. Hopefully it makes sense. All right, so I got my front view. I'm not going to do anything with hidden lines yet. I'm just going to leave it like that. Let's move on into the next view, which is my side view. Grab this guy and fold it again. All right, so now let's focus on the side view. So if I were to look at the side view, and let me put something on top of this. I have, I'm looking that direction. I got 2 and 13/16. I got the 3/8 come from this guy. And in fact, I'm going to go and I'm going to project some of this geometry to the side view. So this is this view. I'm going to use it to project the height. I'm going to use it to project that one. And I'm going to use it again. And again, sorry if I don't project it correctly because I cannot see at an incline. That's that point. I'm just projecting it sideways. And I'm going to use those points. Again, sorry if it doesn't look completely square. I am drawing at an angle. All right, so I got that height, as well as the height of this guy that is on the back. This guy should be hidden line, by the way. Right, because I'm looking at that line. Again, all I did is project the lines. Okay. The width for this one, it seems to me, it is 3/8. So I'm going to come over here. I'm going to do 3/8, and then 3/8 over here. Then it's going to go upwards, and it seems to go upwards all the way till it gets to the end. Upwards all the way till it gets to the end. Boom. And then, so if I were to do the solid lines, it will be this region. I won't have anything here. I won't have anything here, anything there. In fact, I won't have this, and I won't have any of this. Thumbs up. Okay. Next, I need to deal with the hole, and it seems to me that it is an inclined hole. It's this one, right? So let's start by first locating it on the incline. So if I were to go back to the same view that I started with, my hole will be at 1 inch from the starting of the incline, which is, let's say, about right there. And now my hole, it seems to me, it is 1.5, which means I have a radius of 3/4. So 3/4 here and 3/4 there. The whole thing should be 1.5, which it is, right? This is the center, this is the quadrant, there's the other quadrant, which again, we're looking at this 1.5 hole. I'm gonna grab something that is perpendicular 90 degrees, which I'm luckily have a triangle, which I can use. And I'm gonna get that triangle. And you guys don't necessarily need a triangle, you can get yourself something that's square. Maybe you get a piece of metal or piece of paper, something that's square, 90 degrees with each other, that would perfectly work fine. So I'm gonna use that one to come up with a couple of lines. And again, I want to make it super thin because I'm going to trace over them, put it right there. And again, at this point of time, I can go and I can make that one center line. And I can make that one bunch of hidden lines. Hidden. Right. And then hidden. Boom. Now if I were to look at my view, I have the hole, I have the center line, and let's get rid of the excess, which is this one. Again, I haven't made any thick lines, right? You don't want to do any thick lines until you're completely done, sure that your drawing is complete and it's done. I am done with my front view. I need to mess now with my side view. So if I were to look at a hole or a circle, right? The circle is combined of a couple of points. I have that point that is the center, and then these guys here is called the quadrants. If I were to have the hole on an incline, which is our case, I'm looking at that hole. This is the center, this guy, and that guy is the quadrant. So this one and that one, right? If I were to project it on an inclined surface, let's call that surface this surface. That point will be the center. This point will be the bottom quadrant. This top will be the top quadrant. And then this one and that one will be this one and that one, right? Kind of like a wing type of deal. If you were to put them all together, that would be the hole that you would see on an inclined surface. So we're going to do something similar here. I'm going to come over here, grab my ruler. I am going to use the projection of where the hole location is. System is right there. Okay. Make a little construction line super quick. Seems to me have another one somewhere about there. Somewhere about there. Boom. And it seems to me have another one somewhere about there. Boom. Right? And again, based on my drawing, the center of the hole is located at 1 inch from the right side face, from this face. So let's take a look at that. I'm going to come over here at 1 inch. This is where my center is going to be. The width of my circle, it is 1.5, which means I got to move 3/4 on each direction. Boom. That's where my two quadrants are. These are these two quadrants that I just told you about. Okay. Now, I also got in the top quadrant and the bottom quadrant, so I can go grab my ruler. I can make a slight line. That point and that point will be my other quadrants. And now I just gotta make an ellipse. Okay, so how you make an ellipse? I'm gonna grab a line here, on a line over there. I'm gonna go at a diagonal. I'm gonna split this guy into 3. That one into 3, that one into 3, that one into 3. And I'm gonna go here to the 2/3 the way. About 2/3 the way. About 2/3 the way. And about 2/3 the way. And again, sorry if it doesn't look perfect. Again, I am drawing at an incline. I'm drawing that direction. So it's kind of hard to draw. I am going to get rid of all these extra lines that I made. I don't need them. I'm going to get rid of them. Boom, boom, boom. It's good enough for borders, especially doing an incline. Right. Now I'm going to grab, and you guys can see that this hole If I were to continue this whole into space, there will be a surface here, which I'm going to continue, and again, I'm going to delete them later on, but I'm going to continue as if they were to be there. If they were to be there, right? And I'm going to use the lines of projections that I just did to try to find the other one that's on the bottom. So I am going to come over here, let's actually graph those ones, project them down, project, project, and project. Come back over here, grab that one and project, will give me that point. And it seems to me the other one is somewhere on the bottom, which is okay. And there is someone somewhere over here on the top. Project will be there. And remember, the whole idea is because if you were to see a hole here, once you project it into this view, it will look like an ellipse. Right? So it seems to me that I have on my quadrant 1, 2, 3, 4. And here I got my center of my ellipse. In my case, I don't need the whole thing. I just need a portion of the ellipse. So again, you can make a diagonal, split the diagonal, and it will look something like this, right? Something like that. And again, you can also do the other portion of it. I'm not gonna do the whole exercise. Again, I'm trying to get this as fast as possible. So that means that this guy is gonna be a hidden line, like that, and then there will be a hidden line somewhere here, another hidden line somewhere here, and boom, this view is done. Let's get rid of all this mess that I just did. Let's get rid of this mess that I just did. Boom, boom, boom. All these projections that I did as well, we don't need them. And again, keep in mind that I haven't darkened anything yet, right? I don't think I need this one, or this one, or that one. Beautiful. All right, let's work on the auxiliary view. The auxiliary view, how do I do an auxiliary view? I need my triangle. Okay, I'm gonna grab a bunch of lines. I'm gonna go 90 degrees with it. So I'm gonna get every time that I see something that touches that inclined surface, I'm gonna create a line that is 90 degrees with it. So it seems to me it's a continuation of this. I'm gonna put it there. Another continuation of that. I'm gonna put it there. I'm gonna flip my triangle. I'm gonna put it about just a little more about there. And there is someone over here about there. Boom. And again, my lines don't look that great, maybe because I didn't do that 90 degrees. I should have. As I should have. Let me double check. Things gotta look about okay. And it looks pretty 90 degrees to me this point of time, right? Okay, so what I want to do is I want to come up with an inclined surface, a line that is going to be creating my projection line, which I'm going to assume is going to be this one, which in this case is going to be on the side view as this one. That one. That one is going to be the one over here. So I'm going to use a distance, let's say about 2 inches. Let's say about J, and another distance which is going to be about J, and that is going to be the line. So this line is meant to represent that line. Everything that I measure this direction is going to go that direction. So for example, if I want to know the location of this hole, which seems to me, maybe I drew it correctly, this is 1. This guy should be, maybe it's not exactly 1. So it seems to me this guy is about 1/16 based on my thing. So it's not exactly 2 inches. So I want to do 1/16. Oops, sorry. 1/16, which will be about there, and then from there is the 1 inch. So about yay, right? I will do the whole thing. So I'm gonna say I'm gonna close that guy. And again, what I just did is this point right here is that point right there. And again, I'm measuring that way and this way. So from here to there was 1 and 1/16, which is from here to there. And then from here to there is 1 inch. So from here to there, 1 inch. I'm also gonna come over here and make a line that is perpendicular. My hole from the center line, remember, is 3/4 and 3/4. So I'm going to go from the center of the hole, now that I know what it is. And I'm going to move 3/4 and 3/4. And I think I'm done. I need to do another circle. And again, in you guys' case, remember, you will make it into a square, go diagonal, split it into 3, and then make the arc, right? Put something in there so it's a focus. Right, so let's go back, make the circle. And again, sorry if this circle is not perfect. I am drawing at 45 degrees, which makes it so much harder to draw. Okay, we're pretty much done with this view. I just need to get rid of all this mess, including my projection lines, including anything that deals with it. I'm gonna need the center, so I don't wanna completely get rid of it. I'm also gonna get rid of all of this ink line. So what about there? Pretty good. Okay, after this, you guys are gonna get to it. I'm gonna assume that at this point in time you should know what is a visible line. See about there. Then you guys have a not a mechanical pencil, but a real line. Real old number 2 pencil will do just fine. Come over here, get the line the way we want it. Do another one here. And again, sorry if it doesn't look that great. It is, I'm drawing a 45, which makes it much harder. Like that. There's another visible line somewhere here. So over there. And again, everything that is not visible, it means to be thin. Your other thin lines are made to be a little bit thicker. I mean, no, not thicker, but darker, but still thin. And again, you guys will take care of it. I need to move on into the next one. Right. You guys will do nice line weight thickness. We have one over base. You guys will finish your center marks, your visible lines, as well as wrap up the auxiliary view. Okay, let's get to the next one. The next one is a little bit more challenging. Hopefully, I get to finish. I'm gonna put this one somewhere over there. Let me get more smart water because I am running out. Running out smarts. Give me more. Smart water, guys. Okay, this one's a little more challenging. The reason why it's a little more challenging is because we got more dimensions. It's telling you, if you guys could see, it's a little bit blurry. It's not that great. I'm just going to read it to you. It's telling you the sketch should include the front, a partial bottom view. So from partial bottom view, a primary auxiliary view, and a secondary auxiliary view. Okay, so this is our trick. So we got a front, then I gotta do the bottom view. The bottom view is because I have holes that are drilled from the bottom and it has a counterboard. That's what the C stands. This is the counterboard, right? And for that reason, I need to create a bottom view. And then, so I got the front, I got the bottom view, I had an auxiliary view coming this way, and then I have another auxiliary view coming that way, right? Now, I'm going to tell you what is the factor that I chose. And my factor that I chose a 3/4 inch scale. You could also could have used a 1/2 inch scale, but I believe that the 3/4 inch scale is the best fit for this drawing. So if you want to follow the same thing, you guys will use 0.75. Otherwise, you will use a 1/2. Let me see my calculation somewhere. Because I didn't want to do one. Take forever doing that. See if I did it somewhere. And that one I gotta find because I don't want to redo one. Okay, I found it. So this is what you guys see here, right? So the way I did it is I say, you know what? I gotta choose a factor. And then the factor was 3/4. So for you it's 1 to 3/4, right? 3 to 4. 3 inches on the paper is 4 inches in real life. So I made it multiply by 1/4, which is my scale factor. So I went in every dimension that I saw, which again I saw them over here, I multiplied that guy by 0.75. So for example, in this case, I got 2.125 times 0.75, and that gives me about 1.59. See, 1.59. Now, I'm not going to do 1.59 because I don't even know what 1.59 is. However, I have a cheat sheet. What I'm looking is for 1.59. Now, the thing is here that 1.59 is between this guy and that one, right? Between 9/16 and 5/8. So you gotta kind of round up to the nearest 1/16. So let's see what I did. If I were to do 2 and an 8, I did, I think I chose 1 5/8, right? Right. That's how I did. You multiply the dimension that you see on the drawing, multiply it by your factor, and then come up with an, let's say, an increment of a 16. And you guys will notice that I selected certain ones that I made in yellow, and I made in yellow. Why? Because that's the ones that I'm choosing to use. Okay? You can do that exercise. It's not too bad. Just don't have the time to do that exercise. You can grab those dimensions, multiply it by 0.75, and then come up with the nearest 16 of an inch increment. Because I'm going to do it by the ruler, right? And it's going to be by hand. So Believe me, it will make a big difference, especially when you start doing your visible lines. So what you guys see here, this is a reduced version of what would a 3/4 be after I can multiply everything by 0.75. And now I'm going to use this drawing to come up with my other views. So, okay, let's start again a little bit more smart water. I have about 20 minutes to complete this. Now, since I don't have the 20 minutes to complete it, I'm going to be honest, I don't think I'll be able to complete it, especially using the ruler. I am going to do my best to kind of guesstimate based on my knowledge of incline distances, which is kind of hard because if I were to draw it straight at me, it's easier. I can estimate pretty well. I think I can draw with the 1/16 to 1/32 of an inch. Right? I've been drawing a lot. Now, at an incline is a little bit harder, but I'm going to do my best. Let's start by first making a line that is going to give me an idea of what an inch is. So I'm going to put 2 and 9/16. And then once I put the inch in there, it will give me an idea of what it is. So let's start with a let's start with a line that is going to be somewhere about there for the front view. And I'm just going to make it like that. And I'm going to make a little mark to give me an idea of what an inch is. Another one, another inch there. And then I got 9/16. 2, 4, 6, 8, 9/16. Right? And I think that's all I'm going to need. With those, with that 1 inch line, I'll give an idea of what to do next. Right? In terms of how much I should draw. So 3/8 of an inch. That means that is a half, right? That is a quarter. That is 3/8 of an inch. The whole thing is a 1 half. This guy will make it a half. This guy will make it a quarter. That will be about 3/8 of an inch, which make the line that I'm going about to draw about that guy will be about 3/8 of an inch, which is what they're asking me. Pretty good. I'm going to grab that line. I'm going to project it. I'm going to draw it. And remember, it seems to me like the 9/16 is the bottom one, so the bottom one is going to be somewhere about there, right? And again, sorry, it's not completely perfect. I don't have the time. The next one, it seems to me it is a 45-degree. If you guys could see it, it's a 45-degree line right there. And I'm supposed to be moving 9/16 right there. I'm supposed to be moving 9/16. Okay, so 9/16 is what? Well, 9/16 is this. It seems to me it's a little bit over a half. So I am going to about 45 degrees. I'm going to use that 9/16 to let me know where to go. So 9/16 here and 9/16 there. That will be about 45 degrees. If I were to make a line from here to there, it will be 45. And I just got to create one that is about the same distance from here to there, from here to there. That's about 45 degrees. Then I'm going to continue that guy about there. And then I'm going to say that it's about 1 inch. So say this is about an inch. This is about another inch. This is about 9/16. Let's see how close I got. 2 and 9 and oh, it's 2 and 1/16, guys. So 1/16 will be about there. Let's see how close I got it. 2 and 1/16. Okay, so I'm a little bit off by about a 16 of an inch. Why? Because I'm most likely it's my 45 degree. That makes it harder. I'm usually pretty good at drawing at distance. Okay, it seems to be like this guy. It protrudes 3/8, because if this is 3/8, then that one would be 3/8. So I'm gonna go from wherever that guy, and I'm gonna move another 3/8 up, somewhere over there, and then I'm gonna move another. Oh shoot! I messed up, guys. I should have went from the bottom first. See over there. I should have went over here. So that is about 1. That is 1 and a 16. Yeah, I shouldn't have started from here. Right, so 2 and 1/16. I'm just gonna make a line. And again, the 2 and 1/16 is about right there. Let's say that from that 2 and 1/16, I'm gonna come over here about 3/8 is about there. Another 3/8 is about 3/4. Let's say about there. Then I'm gonna make a line that is going to return. And then I'm going to go to the incline somewhere here, still at 45. And then I need to make a radius. So this whole distance should be about 1 5/8. So let's say that is a 1. That is about 1. Let's say that is about 1. That is about a half. And an 8 will be the 5/8. So I want to say about there. And I'm going to close that one. Boom. And boom. Again. With that rule, this is not the greatest, right? But we're going to try to do our best. I think I want to keep it like that. for now. Let's focus on the side view now. I mean the bottom view. So again, I'm going to project things. Project, project. And again, in my case, in here, I don't want to do anything as the holes that I'm doing, because it's this thing that I'm projecting, I'm not getting anything out of it. So I'm going to make the box right here for the bottom view. And my thickness is 3/4 plus 3/8 plus another 3/8. So 3/4 plus 3/8 plus another 3/8 will make it 1.5. So my distance here will be about 1.5. Say about there. So what about there? And maybe 1 there. So let's this one slightly. My guy will look somewhere about there. Somewhere about there. Somewhere about there. I'm gonna come out, make a bunch of wiggly lines. That will be my breakout view. And it seems to me I have distance of 3/8, which again 3/8 is about there. And then 3/8 will be about there. And then I have a distance of a half will be about there. And then I have 1 5/8, so that is 1. That is about a half. 5/8 will be somewhere there. How close am I? I don't know. Let's try to see. Let's see it. I'm about an 1/8 inch off, which it seems to me that is the diagonal that I'm doing, which is cutting an 1/8 to 1/16 to me. You guys will have your ruler, which will keep yourself within what you need. I need to look at my holes. And my holes were also reduced. I have a hole that it is 3/8 of an inch counterbore. So 3/8 will mean 3/16 on each side. So that would be about 3/16 everywhere. Say 3/16, about 3/16, 3/16, 3/16, about 3/16 on each corner for there. And then it's telling me that I have a quarter rail, so that would be about an 1/8 on each side. So that guy will be about my hole right there. Let's put another one somewhere there, somewhere there, somewhere there, somewhere there, somewhere there. That is my bottom view. I just gotta put the rest of the visible lines. I can go to the top view now, and I can find out what it is. So I'm gonna go up. I am going to go up, and then in here I will have the quarter, which will be 1/8 of an inch. Somewhere there, I have a thickness of 3/16, so which means I can go and can project that one. 3/16 will be about there, and boom, boom, boom. And then I got the other one, which again about 1/8 of an inch in terms of thickness. Then come back, boom, 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 boom. Done. Let's focus now on the view that is going to be at 45 degrees. So view that is 45 degrees. I'm going to start from here. Let's do also that one. Start, say about there. Let's flip the ruler, and let's say about there. That one about there. Boom. All right. That is now I'm gonna go and I'm gonna do this one, right, which is my inclined surface. And again, in this case, I'm looking that direction, which is gonna be here. Let's do my incline somewhere about here, somewhere about there. Again, this one is harder because, man, I believe this is my depth. That is my depth, which will be that depth. So let's see if I can estimate it pretty good at a diagonal. Kind of tough, guys. It's kind of tough drawing at the 45 degrees. Okay. As good as I'm going to make it with my angle all being crooked. See about there, right? Then I'm going to go and I'm going to make the line somewhere in the middle. I have the 1 5/8 radius, and again you can grab the ruler and say, okay, 1 5/8. Okay, so this is, by the way, this one probably should do it right, so it will make sense. This is 2 1/16. See, 2 1/16 is here, 2 1/16 there. That one, the swing, I want to make it the right direction. That way it makes you, it gives you an idea of how to do it. So I'm going to do 1 5/8, which seems to me I did something wrong. 1 5/8. This is 1 5/8 is somewhere here, right? So you go and you make that line that is 1 5/8, and then you swing 1 5/8 right there, make a line. Then you swing 1 5/8 again, make a line, and then grab that and connect it. That's how you will make your 1 5/8 radius. Right? In my case, again, it is kind of hard. I'm running out of time. In fact, I got probably 10 minutes left, which is going to make it so much harder to complete. But I'm going to do my best. I have the 1 and 5/8 distance, I can come over here to the side, which is about a half of an inch. Half of an inch will be about there. Half of an inch will be about there. And boom, boom. Get rid of anything that's visible. Everything else, I'm going to make it break line. Boom. Then I am going to come over here and I'm going to be doing the second auxiliary view. In this case, I'm just going to project a couple lines. Boom, 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 and then boom. I'm going to come over here and then I got to come up with this other view. This other view. So I'm going to say, okay, let's start by A, like that. And then my whole part, I think it was 3/4, maybe. Yeah, not 3/4. Let's come over here. And again, all these dimensions are there, right? So it's 3/4. That's what I'm grabbing, that 3/4. Right, so that 3/4 will be about there. Let's say close that guy. They half an inch already have it. I'm gonna go down by 3/16. 3/16 will be about there. Then I'm gonna go inside by 3/16, which will be about there. And then I'm gonna go down by another 3/16, which will be about there, there. And then I'm gonna come back and done. Boom. Get rid of everything that I did that it doesn't make a visible line, like that. And let's get rid of everything that makes a visible line, like that. All right, beautiful. Let's come back. And then you ask yourself, okay, so for my auxiliary view, or for my front view, I actually need a bunch of hidden lines, right? And in fact, if you guys were to look at this line represents this, and then this line represents a line that I gotta make, which will be that one. I also have a bunch of hidden lines here, right? And I have another level that I also need to make hidden lines of, something like that, right? From the top view, I have hidden line, and again, this is an auxiliary view, so it's to your discretion. In my case, I believe it makes sense for me to do is to the discretion, which I believe it would help. And would help projected, right? And would help in the sense of understanding the part. I believe we did I did a pretty good job. The only thing here is that from here to there, from here to here, in this region, I don't have a, let's see, I don't have a solid. So there should be a little jump here. There should be a little jump there, right? Because there is no link. Hopefully it makes sense. Besides that, I believe the rest of it will be you guys doing a bunch of visible lines, a bunch of center marks. Make sure you guys got in your you go and take care of the centering. So now you guys have a better idea of how it should look. But it looks pretty decent drawing at a 45-degree angle with no roller. Okay, we are done. I think I was able to complete it, both of them, or at least give you enough so you guys could actually wrap up your assignment. Let me stop the share. Let me stop the video.